the next kind of topic we want to roll into is how fast something dissolves. So there are three things that affect the speed of dissolving. We're not talking about how much yet. We're talking about how fast we can get something to dissolve. Those three topics are surface area, agitation, and temperature. Okay? Now, all three of these factors come down to one thing. They're all based on how do you get more collisions to happen between the water molecule and the salt, or the water molecule and the polar molecule. Okay, so we want to increase collisions to increase the speed of dissolving. So for surface area, if you crush it up and make as much surface area as possible, you now have more spots for collisions to happen. More spots means more collisions, means faster dissolving. Agitation, if you physically just stir it, what happens there is you're actually moving water molecules that would normally be further away from the crystals closer to them, and you're actually moving the water molecules that have already dissolved crystal away, and you're keeping an even concentration always. So by physically stirring, you're actually providing a better system for more collisions to happen. So again, you get more collisions. Now, temperature is all about kinetic energy. So if we raise the temperature, the particles will be moving faster. If they're moving faster, well, the faster they are, the more collisions that they can have happen. Also, the faster they move, the more energy they have. So more of the collisions will have enough energy to start splitting apart the crystals within those crystal lattice. So all three, a little bit different ways, but all three generate more collisions if you increase them. So if you increase surface area, increase agitation, or increase temperature. Now, if you wanted to slow this down, you would do the opposite. So you'd want to have the least amount of surface area. You would not want to stir it, and you want to make it as cold as possible in terms of slowing the process down. That brings us into this idea of saturation, or what is saturated versus what is unsaturated. Okay? So the term saturated means basically maxing out the amount of solute that can be dissolved into a solution. Okay? This is a qualitative value. It's not quantitative, it's qualitative. If you're unsaturated, then you have less than the maximum. Now there is a special case where you can be supersaturated. When you're supersaturated, what happens is we take a solution and we saturate it at high temperature. Okay? So most solid solute solutions, as you warm them up, their solubility is going to increase. So you actually can dissolve more solute at high temperature than low temperature. So what we do is we make it high temperature, we saturate it, and then we just let it cool down slowly, allowing the solute to stay in solution. For compounds that can supersaturate, what happens as they cool down, they stay locked in solution. What also happens is normally when they cool down, it releases energy. So because they're not recrystallizing and they're staying in solution, they're not releasing the energy that normally happens. So as a result, they hold in some extra potential energy that can be used later. Okay? Now, only certain solutes can do this. Of those solutes, the one that is probably best at doing that is sodium acetate, and we'll see a video of that in a second. And one thing you need to make sure you do is you do not want to disturb the solution or change the temperatures too fast, because if you do that, then the supersaturation will not work. Okay? So if we take a look, here's kind of an image of a supersaturated solution, and to test it or to have the supersaturation break and fall apart, we add a seed crystal. Drop that crystal in. As soon as it hits the solution, the other crystal that should be undissolved or should be in the crystal form grow kind of off that crystal, and as a result, we actually get the supersaturation to break and it releases. The other cool thing that happens, as this releases all these extra crystals and they grow, you actually get a lot of energy to be released, so this gets very hot and it releases a lot of energy. Here's a video of the same process.
The flask contains a supersaturated solution of sodium acetate in water. A small crystal of sodium acetate will be added to the solution. Focus your attention on the portion of the solution to which the crystal is added. Here is the process again in slow motion.
Okay, so to wrap this up then, if you have a solution and you're not sure if it's saturated or not, the way that we kind of tackle that idea is determining saturation. All you need to really do is take a few crystals of your solute and drop it in. Okay, so if you drop them in, and if the crystal comes in and it dissolves, you knew you were unsaturated. If the crystal comes in and it does not dissolve, it sits on the bottom, you knew that you were saturated. If the crystal comes in and creates that effect that we just saw, where all these extra crystals come out of that and you have more solid forming, you know that you were supersaturated. Okay, thanks guys.